Hello, we're going to look at Chapter 1, Section 7 in this video. This section is going to deal with inequalities. So first, just a little review. At the top of this sheet, we have recall. An inequality is an expression comparing values, and we use the following symbols. So greater than, we also have greater than or equal to, less than, and less than or equal to. Right, so we're going to look at those four. Now, you can think of greater than and greater than or equal to as meaning a similar thing when you're solving. And when we write our solutions, it is a little bit different on including endpoints. Similarly with less than and less than or equal to, we treat those in a similar way when we solve inequalities, but when we write our answers, they're going to look slightly different. Okay, so let's talk about what we have here in the middle portion. Right? Solving an inequality. So what does that mean? When we say we're solving an inequality, we are finding the set of numbers that make the inequality true. Okay? Right, so find the set, and that's the important word here, of numbers that make the inequality true. And the reason the word set is important is because we do not just have a single value, we'll have a range or multiple values that could be answers here. Okay, our second statement says that the solutions of an inequality make up it's called a solution set. All right, so when I refer to the answers, there will be more than one, I call it the solution set. Okay, we have two different types of notation we can use. Solutions of inequalities can be written in what we call interval notation or set builder notation. For our purposes, we are going to focus on using the interval notation. Now, when I use that word interval, what that means is I'm describing the collection or the set of answers. And we have different ways to indicate intervals. We have what we call open intervals. Those are going to be things that look like an ordered pair, right? It's written with parentheses, but it means the answer is between two numbers. In this case, I'm using the letters A and B, but it doesn't include those numbers. All right, so you would use open intervals when you have things like less than or greater than, right? There's not an equal sign in them. Okay, closed intervals, that means we include the endpoints and we use brackets. So that might be something like less than or equal to, so it may have an equal sign. It may have a greater than or equal to. So when you see the equal symbol, it means you're going to use the closed bracket somewhere. Okay, if they're half open, then it may be something like where you have a parenthesis on one end and a bracket on the other. You could have it reversed. The bracket could be to the smaller number on the left and the parenthesis could be to the larger number on the right. And then we also have infinite intervals, and those are intervals that deal with infinity. So you might have negative infinity up to a number, or you may have a number up to infinity. Now, the symbols around your numbers, this could be parentheses or it could be brackets. It does depend on what your inequality is, but the important part to notice is that whether I have infinity or negative infinity, you will always use parentheses around those symbols no matter what. So if you use infinity in an answer, it must have parentheses. It could never have brackets. All right, so that's what our notation is going to look like. Now, let's talk about, and this is going to be the easiest type first, is linear inequalities. And they will look very similar to linear equations, and we'll use similar techniques. All right, so if I had a linear equation, I would want to isolate x, and then I would want to write my answer from there. Okay? So our technique for solving a linear inequality is going to be isolate x, and we're going to say on the left. Okay, so the left-hand side. That way we can write our solution set, or our interval is going to be easier to write. Now, something to notice, and I've got this over here as a caution. When we multiply or divide both sides of an inequality by a negative number, so if I'm changing something or moving a number by multiplying or dividing and it's a negative, what that does is it will change the direction of the inequality symbol. So let's put the direction of the inequality is reversed. Okay, so if I multiply or divide by a negative, the inequality's direction will be reversed. Okay, and we'll see that in just a few minutes here with some examples. All right, so here's an example of a linear inequality. We know it's linear because it only has its highest exponent is x to the first. And I want to solve this by isolating x on the left-hand side. And then I would like to write my answer as an interval. Okay, so first we notice that x is on the left, but it's not isolated. So I need to move some numbers away from x. I'm going to subtract 2. And I treat the inequality symbol just like an equal sign. So I'm acting like I'm moving things across an equal sign. This time it's an inequality. So these would give me 0. I would have negative 3x is less than or equal to 3. And now I'm going to divide both sides by negative 3. Now, notice what happens. I'm dividing by a negative. So what that tells me is I'm going to reverse the direction and keep my answer as negative 1. So this solution says the x's that are greater than or equal to negative 1. So imagine if I were to draw that on a number line. Okay, that means I would start at negative 1, and anything greater is going to be moving to the right-hand side. So in an interval, I would say negative 1 is the smallest number. I continue going to infinity on the right-hand side, and I would answer with a bracket. Now the reason I use a bracket is because of the equal sign. If I did not have equals, I would use parentheses. So any number in this interval that I choose would make that inequality true. So let's choose an example. So for example, 0 is in that inequality. So when I substitute 0 for x, I should get a number that is less than or equal to 5. So 2 minus 0, which is still 2, and that's true. And again, I could pick any other number in this interval. I could pick a very large number, right? Because the interval goes to infinity. I could pick 300, and I would still come up with a solution that is less than or equal to 5. All right, so that's your technique for solving linear inequalities. Okay, now let's move to a new type of inequality. All right. So this is an inequality that would combine two simple inequalities, and we call that a compound. All right, our technique for solving compound inequalities is, again, we want to isolate x, but our location is different. Instead of being to the left side of the inequality, we want isolate x in the middle, or we could say between the inequality symbols. So let me show you an example. Okay, this example is what we would call a compound inequality, right? Compound because I could look at this side as a simple linear inequality, or I could look at this side as a simple. So it takes two simple linear inequalities and it puts them together to form a compound. All right, now let's solve this. So my solving technique is that I want to isolate x, and I want the x to stay in this area. Right? I don't want to move it out of what we call the middle or between the two inequalities. So my first step is I want to move this 3. All right, so I'm moving the 3 by subtraction. Now notice I'm subtracting it from the middle expression, from the constant that's on the right, which is the 11, and the constant that's on the left. So I have to do this 3 times. All right, so I would have -2 is less than or equal to 2x is less than or equal to 8. Okay, so the subtraction in the middle removed the +3. Now, I still would like to keep x between the two inequality symbols, so I would divide by 2. Now, I'm dividing by a positive number, so that does not change the direction of the inequality. Next, I simplify. So I get just x in the center. So that means I have -1 less than or equal to x is less than or equal to 4. Now, let's just imagine what would that look like on a number line. And then how would I write the interval? Right? So the equal sign next to a number indicates that I include that number. So for this left portion, -1 is going to be the smallest value. Then I'm going to choose any x that goes up to 4, but I will not include 4 because it does not have the equal to symbol. All right, so all the numbers in here, so up to 3.9999, but not equal to 4. Now, in an interval form, I just take the two numbers that I have in my solution, I put a comma between them, and then I determine would I use parentheses or brackets to include or exclude the endpoints. So the -1 has an equal sign next to it, so I would include it with brackets. The 4 does not have the equal sign, so I would only use parentheses. All right, so that's your solution for what we would call a compound inequality.